Hey guys, today we're going to be talking about a new exponent property called power of a product. Okay, this is a little bit different than what we've been looking at before, but we'll make it all right. Okay, so before you've been having variables to an exponent, but you haven't had any coefficients that were larger than 1. And today you're going to have to play with that a little bit. Okay, so what does 32k squared mean? Well, that just means it is 32k multiplied by itself 2 times. Okay, so if you have 32k squared expanded, that would mean you have 32k times 32k. Okay, but what if we further expanded that out? You broke it down without the parentheses. That means you would have a 32 times a k, and then another 32 times a k. So that's what that would look like without parentheses. Now, if we put everything together that's similar, that means 32 times 32 times k times k. We're just rearranging items. Okay. Now, what if we wanted to rewrite this this thing in an exponential form real quick? What if we wanted to rewrite it in exponential form? You could write it 32 times 32 is also known as 32 squared, and k times k is k squared. Well, if you compare that result to our 32k squared over here, what do you notice? Okay. Well, if you have an exponent on the outside and you have a coefficient larger than 1 and a variable, you're going to want to distribute that that exponent to each of those things. So we have 32 squared, k squared. Okay, and that's where we got our solution over here. Okay, so let's try another one real quick. This time you have PA squared. Okay, so if you expanded that, PA squared means PA times PA. And if you expanded that further, you would have P times A times P times A, or I guess it looks like Papa. But anyway, if you reorganize those to have the similar terms together, you would have P times P times A times A. And then again, if you wrote that in exponential form, P times P as an exponent would be P squared, and A times A would give you A squared. Now, all this work we did was quite a bit of work. It's not even really necessary. Okay, if you compare it to our original, P times A squared, if you go ahead and distribute that exponent to the P and the A, you just have P squared A squared. Okay, so that makes our job a whole lot easier. Okay, so for power of a product, I want you to write down the summary. Write down power of a product, power of a product, and I want you to write down to find a power of a product, to find the power of a product, put the exponent with everything inside the parentheses. Okay, so to find a power of a product, put the exponent with everything inside the parentheses. Okay, so let's go ahead and try a few. Okay, so if we look at that first one, you have 4u cubed. So we're going to distribute that exponent to each of the things inside. So 4 cubed, u cubed. Okay, but remember, you cannot have a whole number with an exponent on it if you want to be done. So what's 4 cubed? Well, 4 times 4 is 16. And 16 times 4 would give you 64. So your final result would be 64 u cubed. Let's try another couple. Okay, that box should be a negative. So you have negative 9x squared. So if you distributed that, you would have negative 9 squared x squared. Well, what's negative 9 times negative 9? A negative times a negative is a positive, so that would give you an 81x squared, and that would be our solution. You had to distribute and reduce there. Okay, let's try another one. Again, you're distributing. You would have 2 to the 6th, and then w to the 6th. Well, if you take that on your calculator, 2 to the 6th, 2 times 2 times 2 times 2 times 2 times 2, it's a mouthful, you would have 64 w to the 6th. And if you wanted to type that into your calculator, 2 to the 6th, you would type in your 2 caret sign 6, enter on your calculator, and that would give you your solution of 64. And let's try one more. And this time we're distributing that 2 to the x and to the y, so you would just have x squared, y squared. Okay, so that's our rule on a few examples. Let's look on the back and try to come up with a few that might be a little bit more difficult. All right, before we get started, I got a quick joke for you. What does the Lone Ranger say when he takes out the garbage? Think about it. Think about it. To the dump, to the dump, to the dump, dump, dump. You like it. I know you do. All right, let's try a few. Okay, so again, we're trying our power of a product rule if your coefficient's larger than 1. So we're going to take our exponent and distribute it to each one of these variables. Okay, so we now have 3 squared, b squared, and c squared. Okay, b squared and c squared are good, but we cannot have a whole number with an exponent on it and be done. Okay, so what is 3 squared? That's also 3 times 3, which we know to be 9. So 9b squared, c squared would be our solution in this case. Okay, let's try a couple more. Hey, this time on this problem, you don't have coefficients that are larger than 1. They're both 1, so we can go ahead and use our power of a power rule. What does the power of the power rule say? Well, it says that you want to take your exponent and multiply it by the exponent on the outside. Okay, so j squared times 3, 2 times 3 is 6, so we now have j to the 6th. And then you have k to the 3rd times 3, which would give us k to the 9th. Simple as that. You don't have to do any further reductions or simplification. You can leave it just like that. Okay, now let's try this guy. If you distributed him, we would have 4 to the 5th. And then a squared times 5. 2 times 5 gives us 10. So we have a to the 10th. And then b to the 1st times 5, that would give us b to the 5th. All right, so if we want to go ahead and reduce that 4 to the 5th, you can get your calculator and type in 4 caret sign 5, and you would get 1,024. Okay, so 1,024, a to the 10th, b to the 5th would be our solution in this particular problem. All right, let's move on. We have a few more here and then we'll be done, I promise. All right, 2 more. Okay, so on this one, make sure that you have a multiplication sign and a negative up here on your 4. Okay, so first thing we need to do is go ahead and distribute our 2 exponent to the 5. So 5 squared, which is 25, d squared times d to the negative 4. Okay, so if we want to go ahead and reduce our exponents, we know that they're multiplied together, they're the same base, so we can add them. So 2 plus -4, of course, gives us -2. So we have d to the -2, but we don't like negative exponents. So what do we do to them? We kick them down to the bottom. So 25 stays up top, d squared goes to the bottom. And that would be our final solution. Okay, last one, then we will be done. All right, on the last one, make sure that you have a multiplication sign on here. Okay, so let's go ahead and distribute our exponent. So we would have 2 to the 6th, and then r to the 3 times 6, power of a power property, 3 times 6 is 18. So we have r to the 18 and s to the 6, because 1 times 6 is 6. And we also have times s to the 8th. Okay. Now if we plug in 2 to the 6th on our calculator, 2 times 2 times 2 times 2 times 2 times 2 is going to give you 64 r to the 18th. And then since you have the same base for your s's, they're multiplied together, you can add their exponents. Okay, so if you add 6 and 8, that would give you s to the 14. And that would be our final solution for this guy. So if you really take these piece by piece, they're not so bad. You just got to remember each of your exponent properties and apply them to each problem. See ya.